I want you to picture your morning today. Probably woke up, maybe grabbed your phone before you even got out of bed.
Hmm.
You scrolled through a feed curated by an algorithm. You might have asked a smart speaker for the weather. If you drove to work in a car that, nudged the steering wheel when you drifted a little too close to the lane marker.
It's seamless, isn't it?
That's the word. Seamless. It's
Yeah.
everywhere. It's writing emails. It's optimizing supply chains. It's
Yeah.
it's diagnosing rare diseases in hospitals.
Yeah.
It feels magical.
It really does.
It feels like we've finally arrived in the future we were promised.
It feels magical until the moment it isn't.
Exactly. Until the magic trick goes wrong. And that is the massive, complex, and frankly terrifying question lurking behind all this shiny technology. What happens when it breaks?
And we're not talking small breaks.
No, I don't mean, oops, the chatbot gave me a weird recipe for pizza.
No, we're talking about, oops, the autonomous vehicle just made a decision that endangered a pedestrian. Or oops, our hiring algorithm has been systematically rejecting qualified candidates for 3 years and nobody noticed.
Right. And when those things happen,
Yeah.
it's not just a tech support ticket. It's a lawsuit. It's a PR disaster.
Right.
It's a genuine societal harm.
Absolutely.
So today, we're doing something a little different on this deep dive. We aren't looking at the latest flashy model release.
Right.
We aren't hyping up the newest features.
We're looking at the rule book.
The safety manual.
We are peeling back the curtain to look at the structural steel holding the building up.
We are doing a deep dive into BS EN ISO IEC 23894.2024.
A title only a bureaucrat could love.
It rolls right off the tongue. But stick with us, because this document is, believe it or not, fascinating. It's the Standard for Guidance on Risk Management for AI.
Which is a very dry way of saying.
It's the instruction manual for how organizations, whether they're massive tech giants or small startups, are supposed to keep their AI from going off the rails.
And it's really important to clarify right up front what this document actually is. This isn't a technical manual on how to code a neural network.
No Python scripts in here?
You won't find Python scripts in here. It's a management standard. It bridges the gap between generic risk management, the kind of stuff companies do for financial audits or workplace safety, and the absolute Wild West that is artificial intelligence.
The Wild West is a great way to put it, because for a long time, it felt like we were just making it up as we went along.
Move fast and break things.
Exactly. Move fast and break things. Right. But this standard, it lays down the law, or at least the guidance. Our mission today is to unpack how this document tells us to identify, analyze, and treat the specific and honestly sometimes bizarre risks that come with AI.
And there are some truly bizarre ones in there. The authors of this standard clearly have some active imaginations, or
they've seen some things.
they've seen some things.
Yeah, we are going to get to those. I saw something in the notes about cosmic rays, and I need to know more immediately.
We will absolutely get to the cosmic rays. It's one of my favorite parts of the annexes.
Okay, good. Ideally, before they flip a bit in my laptop and delete this recording. Okay, let's orient ourselves. Here is our roadmap for the hour.
Let's do it.
First, we're going to look at the core principles. How is managing AI risk different from managing, regular software risk? Second, we'll look at the context, the environment where the AI lives, because apparently context is everything.
It is.
Third, the process itself. How do you actually hunt down the bad stuff? And finally, we're going to spend a good chunk of time on the annexes.
The juicy details.
That's where the juicy details are. Data poisoning, zombie AI, and yes, space radiation.
Sounds like a solid plan.
Let's jump into segment 1, the philosophy. Why is AI risk different? This standard, ISO IE 23894, it doesn't exist in a vacuum, right? It's related to something else.
Correct. It creates a relationship with its parent standard, which is ISO 31000.
ISO 31000.
Now, if you work in corporate risk, ISO 31000 is your Bible. It outlines how to manage risk in general. Whether you're running an oil rig or a bank, 31000 is the framework.
So it's the generic playbook.
It's a generic playbook. This new document, 23894, essentially says, okay, take all those general rules, but here's how you have to tweak them specifically for artificial intelligence.
It's like the specialized expansion pack for a video game.
Oh.
The base game rules apply, but now there are dragons.
Precisely. And in Clause 4, they lay out the principles of AI risk management. Now, some of these look familiar if you know the parent standard, but the implications are unique. The standard explicitly lists implications for the development and use of AI.
Okay, so let's walk through the big ones. The first one in Table 1 is integrated. Now, that sounds like corporate buzzword bingo. We need integrated synergy.
He chuckles. It does.
But what does it actually mean here?
It means risk management cannot be a side department. It can't be an afterthought. You can't build an AI system, get it ready to launch, and then knock on the door of the risk department on a Friday afternoon and say, hey, can you sign off on this so we can ship it?
Which, let's be honest, is how a lot of software gets built.
It is.
The engineers build the thing and the lawyers clean it up later.
Exactly. And that is catastrophic for AI. The integrated principle says risk management has to be part of the AI's DNA. It has to be an integral part of organizational activities.
So from day one.
From the first meeting. If you are designing the model architecture, you are managing risk. If you are collecting the training data, you are managing risk. It's not a separate phase, it's the whole job.
So it's everyone's problem.
It's everyone's problem. You can't outsource safety to a checklist at the end.
Okay, that makes sense. Next one, customized. One size does not fit all.
This is crucial because AI is a massive bucket term. We use the same word for a chatbot that recommends songs on Spotify and an autonomous surgical robot that operates on human hearts.
I would hope the risk protocols for those two are slightly different.
You would hope so. If the music bot fails, you have to listen to a polka song you didn't want.
Annoying.
It's annoying, but nobody dies. If the surgical robot fails, well...
The stakes are infinitely higher.
Exactly. So the standard explicitly says the framework must be customized and proportionate to the organization's external and internal context. You can't just download a generic AI risk checklist from the internet and apply it to everything.
A boilerplate.
No. You have to look at your specific tool, your specific objectives, and your specific blast radius if things go wrong.
Now, this next one I found really interesting. Inclusive. Usually when I think of building tech, I think of developers and engineers in a dark room with headphones on.
Right.
But this standard demands more people be involved.
It's a very progressive point for a technical standard. It calls for the appropriate and timely involvement of stakeholders. And here's where it gets really interesting. The standard notes that stakeholders provide views on perceptions of risk.
Perceptions of risk. Let's unpack that. That sounds like feelings. Are we talking about feelings in a technical standard?
We are. Because in AI, perception matters almost as much as technical reality. The standard mentions that stakeholders can have knowledge, views, and perceptions that need to be incorporated.
So, not just facts and figures.
No. Think about the black box problem.
The idea that we don't know how the AI makes its decisions is just opaque.
Right. Now imagine you deploy an AI tool to help with employee performance reviews. Let's say technically it's actually very fair, it's unbiased, it's mathematically perfect, but nobody understands how it works. It just spits out a score.
Everyone is going to assume it's biased against them. The machine hates me.
Exactly. And that lack of trust, that perception of risk, causes the implementation to fail. The employees revolt, or they game the system, or they sue. The outcome is the same as if the machine actually was biased.
So being inclusive means you have to talk to the people who are going to be affected by the AI, not just the people building it.
You have to ask them, what are you worried about, before you write a single line of code.
So you're essentially doing focus groups as part of your risk management.
You have to. You need to bring in sociologists, ethicists, the actual end users. Otherwise, you're building a solution that the real world will reject, even if the code is bug-free.
That brings us to what I think is the biggest differentiator. The dynamic principle.
Yes. This is the smoking gun. This is why AI is not just software.
Standard software is static, right? If I install a word processor on my computer today and I never update it, it works exactly the same way in 5 years.
Correct. Standard software is deterministic. It stays where you put it. AI drifts.
It drifts.
AI is dynamic. The standard explicitly states, risks can emerge, change, or disappear as an organization's external and internal context changes. And more importantly, the AI system itself can change.
Because it learns. Or at least some of them do.
Some learn continuously, yes. But even if they aren't learning in real time, the data feeding them changes. The world changes. We call this concept drift.
Give me an example of concept drift.
Okay, imagine you trained a model to predict housing prices using data from 2010 to 2019. The model is a genius. It predicts prices within 1% accuracy. You deploy it.
Sounds great so far.
Then 2020 hits, the pandemic, remote work explodes, everyone moves to the suburbs.
The market flips upside down.
The model hasn't changed, the code is identical, but the reality it represents has shifted completely. The fundamental rules of the housing market are different.
So the model is now working with old assumptions.
Terribly old assumptions. Now, that same model is making terrible, risky predictions. The risk profile has shifted because the environment is dynamic.
So risk management can't be a set and forget checklist. It can't be, we did the audit in January, we're good for the year.
It has to be continuous. It's a loop. I like to use the analogy of building a bridge versus raising a child.
Okay, I'm listening.
When you build a bridge, you do a lot of risk management up front. Engineering, materials, stress testing. Once it's built, you do maintenance, sure, but the bridge isn't going to wake up one morning and decide to be a tunnel.
I should hope not. That would be a terrifying commute.
But an AI is like raising a child. It interacts with the world. It picks up bad habits. It encounters situations you didn't anticipate. It learns new slang.
Chupples. Okay.
You have to be constantly watching, guiding, and correcting. That is what the dynamic principle demands. You are parenting the algorithm, not just building it.
That's a great way to think about it.
Yeah.
And connected to that is the final principle I want to touch on. Human and cultural factors. The standard acknowledges that AI interacts with human behavior.
Right. Clause 4, Table 1 mentions taking into account human behavior and culture. An AI that works perfectly in one culture might be offensive, biased, or simply useless in another.
Would you give me an example of that?
Think about a facial recognition system or an emotion detection system. These are becoming common in hiring or security.
Right.
In some Western cultures, maintaining eye contact is a sign of confidence and honesty.
Look me in the eye and tell me the truth.
Exactly. But in other cultures, parts of Asia, the Middle East, many indigenous cultures, prolonged eye contact can be seen as aggressive, disrespectful, or a challenge to authority.
So if you train an AI on data from New York, and then you deploy it in Tokyo to judge job interviews,
It's going to misinterpret the body language completely. It might flag a polite, respectful candidate as suspicious or lacking confidence.
and that creates a risk, not a bug in the code. The code is doing exactly what it was told to do.
Exactly. The risk comes from the cultural mismatch. The standard requires you to factor that in. You have to ask, where is this system going, and do the rules of behavior change when we cross a border?
Okay, so we've got our principles. We know we need to be integrated, customized, inclusive, dynamic, and culturally aware. Now let's move to segment 2, knowing the territory, the context.
This is covered in Clause 5 and Clause 6.3. Before you look for risks, you have to define the playground. The standard breaks this down into external context and internal context.
Let's look at external first. This is Table 2 in the source documents. It's not just about the tech stack. It lists things like legal requirements.
Which are exploding right now. We have the EU AI Act, we have various executive orders in the US, rules in China. The legal context is a minefield.
It's changing month to month.
It really is. If you are building an AI, you need to know, is this considered high risk under the EU AI Act? If so, your risk management obligations just tripled. That's a huge external factor.
It also mentions ethical guidelines. These are softer, right? Norms issued by civil society or academia.
They are softer until they aren't. Ethical guidelines drive public opinion. If you violate them, you might not go to jail, but you might get boycotted.
You end up on the front page of the news.
Exactly. The standard specifically highlights stakeholder perceptions here again, mentioning the opaqueness of AI, the black box problem.
The idea that we don't know how it works effectively lowers the trust threshold.
Exactly. If people perceive your tool as a mysterious black box that makes decisions about their lives without explanation, the external context is hostile. You are launching into a hostile environment. You need to manage that risk, perhaps by focusing heavily on transparency, which we will discuss later.
Then there's the internal context. Table 3. This is looking in the mirror.
It is. It asks hard questions about the organization itself. One key element is data flows. Where is the data coming from? Who owns it?
That seems basic, but I feel like a lot of companies scrape the web and just say, well, it was on the internet.
And that is a massive risk. We are seeing lawsuits right now regarding copyright and AI training data. The standard says you need to understand your data flows as part of your internal context. If your foundation is stolen data, your risk tower is wobbling.
Another point in internal context is capabilities. Does the organization actually have the talent to manage a neural network, or are they just guessing?
This is the don't kid yourself clause. It asks you to evaluate your resources. Do you have the capital? Do you have the time? Do you have the people?
The human element.
Right. Using an AI system requires specific knowledge. If you buy a complex AI tool, but your IT team only knows how to reset passwords, you have created a massive internal risk. You have a Ferrari engine in a go-kart, and nobody knows how to drive it.
There is also a specific mention in the internal context about trade-offs. It mentions impact on transparency and explainability.
This is the classic AI dilemma. Often, to get better performance, a smarter, more accurate AI, you have to use a more complex model like deep learning.
Okay.
But deep learning is harder to explain. It's less transparent.
For you to choose, do I want it to be 99% accurate, but I can't explain why, or 90% accurate, but I can show my work?
Exactly. And the standard says this is a contextual choice. If you are recommending movies, go for the 99% accuracy. Nobody cares why Netflix recommended an action movie. But if you are denying a mortgage application...
You better be able to explain why. There are laws about that.
Yeah. Right. So the internal context requires you to define those priorities. What matters more to us right now? Performance or explainability? You can't usually have both at the maximum level.
This leads us to defining the scope in Clause 6.3.2. Why is this so important?
Because you can't manage risk for the internet, or AI in general. You manage risk for this specific tool in this specific context.
You have to draw a box around it.
You have to draw a box around it. The standard emphasizes setting boundaries. You have to say, we are assessing the risk of this chatbot only for customer service inquiries in English.
Because if someone tries to use it for medical advice or in Spanish, that is outside the scope.
And if it's outside the scope, you haven't risk assessed it for that. You need to define those guardrails so that if the system crosses them, you know you are in unmapped territory.
Okay, so we have our principles, we have our context. Now let's get to the work. Segment 3, the assessment. Clause 6.4, identifying the dangers.
This is the core of the risk management process. Identification, analysis, evaluation.
Let's start with risk identification, 6.4.2. The standard talks about identifying assets at risk. And it's not just the hardware, is it?
No. I mean, sure, tangible assets are listed, the hardware, the data itself. If your server melts, that's a risk.
Pretty straightforward.
But the standard places a huge emphasis on intangible assets, reputation, public trust, and crucially, individual rights.
Individual rights. That's a heavy asset to list in a corporate risk document.
It is, and it reflects the power of AI. If you deploy a biased algorithm, the asset that is damaged isn't just your stock price. It is the civil rights of the people who are discriminated against.
So the harm isn't just to the company.
It's to society. The source explicitly mentions impacts on democracy, environment, and cultural diversity.
Democracy. Wow. So if I'm building a content recommendation engine, I actually have to ask, could this damage democracy?
According to ISO IEA 23894, yes. That is a potential societal impact. You need to think about filter bubbles, misinformation, polarization.
With a huge responsibility.
It elevates the stakes significantly beyond just profit loss. You have to think about the broader ecosystem.
Then we move to risk analysis, 6.4.3. We have to look at consequences.
And here, the document requires a distinction. You must distinguish between the impact on the organization and the impact on individuals or society.
Give me an example of how those differ.
Okay, let's look at the specific detail from the text. Employee recruitment and retention. Let's say you implement an AI to monitor productivity.
The classic bossware.
Right. The impact on the organization might be positive productivity goes up by 5%. Great. That's a positive consequence for the org.
Looks good on a spreadsheet.
But the impact on the individuals, the employees, might be massive stress, burnout, and a feeling of being spied on.
Which eventually circles back to the organization because everyone quits.
Exactly. The text mentions work time gained and lost. If the AI makes people quit, you've lost work time. So the analysis has to look at both sides of the coin. You can't just look at the bottom line, you have to look at the human line.
Now, when we analyze risk, we usually look at probability and consequence. How likely is it to happen, and how bad will it be? But the standard says calculating likelihood for AI is tricky.
Tricky is polite. Clause 6.4.3.3 mentions heuristic issues.
Fancy words for we are guessing.
Basically, it's hard to calculate the probability of an AI failure because AI is probabilistic itself. It's based on large margins of error.
It's not a simple machine.
No. With a traditional machine, say a piston in an engine, we have physics. We know that after 1 million cycles, it has a 0.01% chance of cracking. We can calculate that.
With a neural network.
We don't have that physics. We don't know exactly why it decides what it decides. So determining the likelihood of it outputting a specific harmful sentence is very difficult.
So you can't put a hard number on it.
And the standard warns that heuristic biases, our own mental shortcuts, can lead us to underestimate or overestimate these risks because the math is so fuzzy.
So we have to be humble about our predictions.
Precisely. You can't rely on false precision. Don't say there's a 12.5% chance of failure. You just don't know that. You have to use broader categories and qualitative assessment. High, medium, low.
Moving on to segment 4, the objectives. This is Annex A. This is essentially what good looks like. If we are managing risk, what are we trying to achieve?
Annex A is a goldmine. It lists the objectives that should guide your risk treatment. It gives you the targets.
Let's talk about two that often get confused. Transparency versus explainability. They sound the same. A12 and B.3 cover these. What is the difference?
It is a critical distinction. Transparency is about openness regarding the process.
Okay.
It's about declaring how the system was built, what data was used, what the intended scope is, and what the limitations are. It's like the nutrition facts label on food. It tells you ingredients and calories.
Okay, so transparency is the label. What is explainability?
Explainability is the ability to explain why a specific decision was made. If transparency is the label, explainability is the chef coming out and explaining why the soup tastes salty.
I added salt.
Right. But with AI, specifically deep learning, we often have the black box issue. We can be transparent, we use this data, we use this model architecture, but we might lack explainability.
The chef says, I don't know, it just felt right.
Exactly. We might not be able to say why the model rejected your loan application. It just did. The math said no, and the path through the neural network is too complex to trace.
And Annex A suggests this conflict is something to manage.
Yes. You might meet the objective of transparency, but fail the objective of explainability. You need to decide if that is acceptable for your use case.
Let's talk about fairness. Annex AG6. We touched on this, but the text mentions automation bias. What is that?
This is a risk that comes from the humans using the AI. Automation bias is the tendency for humans to blindly trust the machine.
Computer says no, so it must be right.
Exactly. Even if the human is supposed to be the final decision maker, if the AI says high risk, the human rarely disagrees. They just rubber stamp it.
So the human becomes a cog in the machine's process.
And this creates a fairness issue. If the AI is biased and the human is biased toward trusting the AI, you have a feedback loop of unfairness. Managing fairness implies training your humans to doubt the machine.
I like that. Objective. Train humans to be skeptics. Next one. Accountability, A2.
This is simple but vital. The AI cannot be the legal entity. You cannot sue an algorithm.
I'm sorry, Your Honor. The neural network pleads the fifth.
Chuckles. Exactly. It doesn't work. The standard distinguishes between system accountability and organizational accountability.
What's the difference there?
System accountability might be about logging who did what and when. But organizational accountability means someone, a human or a corporate board, must be responsible. You have to trace the decision back to a person. If you can't, you have failed the accountability objective.
Privacy. This one scares me a bit. Talks about the risk of inference.
This is the Sherlock Holmes risk. Even if you don't give the AI your private medical records, can it guess your health status based on your shopping habits?
Like that famous story where the store knew a teenager was pregnant before her father did, just based on what she was buying.
Exactly. AI is incredibly good at finding correlations. The standard warns that improper collection or disclosure isn't just about leaking data, it's about inferring sensitive data from non-sensitive data.
So even if the data is anonymized,
the AI might re-identify people or infer their private conditions just by connecting the dots. That is a massive privacy risk that goes beyond traditional data protection.
And finally, for this segment, sustainability, A.5.
The environmental impact. We often think of AI as the cloud, which sounds fluffy and light.
Right, it's just out there somewhere.
But the cloud is rows of servers burning massive amounts of electricity and drinking water for cooling. Training a large model has a huge carbon footprint.
I've seen some staggering numbers on that.
The standard says you have to count that. That is a risk to the environment. If your AI aims to save 1% on logistics costs but burns a forest worth of carbon to do it, have you really won?
That is the ultimate trade-off question. Okay,
Yeah.
Now we get to the part I've been waiting for. Segment 5, the source of nightmares. Annex B. Where do the risks come from?
Annex B is where the rubber meets the road. It lists the risk sources.
Let's start with complexity of environment, B2.
This goes back to where the AI lives. AI works best in predictable environments. A chessboard is predictable. The rules don't change.
There are a finite number of moves.
Right. The real world? Not so much.
The real world is messy.
The standard notes that Unpredictable environments are a major risk source. Think about autonomous driving. It is relatively easy to teach a car to drive on an empty track. It is incredibly hard to drive in a city with erratic pedestrians, construction zones, bad weather, and other drivers breaking the rules.
So the risk source isn't the car, it's the chaos of the world.
Correct. The domain mismatch is a huge risk here. If you train the car in sunny California and deploy it in snowy Norway, the environment has changed complexity levels.
It's a completely different problem.
And the AI might fail catastrophically because it doesn't know what snow covering a stop sign looks like. It's never seen it.
Then there is machine learning specifics. BCI-5, data quality.
Garbage in, garbage out. If your training data is flawed, your model is flawed. That's the basics. But the standard gets darker. It mentions data poisoning.
This sounds like a spy novel.
It is a specific attack vector. Bad actors can intentionally feed the AI bad data to break it.
How would they do that?
Imagine you have a spam filter that learns from user feedback. If I'm a spammer, I could create thousands of fake accounts and mark my spam emails as safe.
You're polluting the training pool.
I am poisoning the data set. The AI learns that my Viagra ads are actually important business correspondence. The system is compromised from the inside.
Or painting a few pixels on a stop sign so the self-driving car thinks it's a speed limit sign.
Exactly. That is an adversarial attack. The standard highlights this as a unique risk source. You don't just have to worry about bugs, you have to worry about enemies poisoning your AI's food supply.
Okay, expert, it is time. Hardware issues, B6. The notes say the document lists, and I quote, soft errors such as unwanted temporary state changes caused by high-energy radiation.
Chuckles. Yes, cosmic rays.
We're talking about space radiation flipping switches in our AI. For real.
We are. It sounds like science fiction, but at the scale of massive computing clusters, it is a real statistical probability. A high-energy particle from space, from a supernova millions of light years away, strikes a chip and flips a 0 to a 1 in the memory.
And in a normal program, maybe that just crashes the app.
Right. Annoying, but you reboot. But in a neural network, that bit might represent a weight, a decision-making parameter. It's a fundamental part of the AI's brain.
So if that weight gets flipped,
the AI might suddenly decide that a cat is a toaster, or that a red light is green.
That is terrifying. The idea that a star exploding a billion years ago could cause my car to crash today.
It emphasizes the fragility of these systems. The standard lists hardware errors based on defective components and these soft errors. It implies you need redundancy. You can't trust a single chip with a life or death decision because, well, the universe might interfere.
Unwanted temporary state changes. I'm going to use that excuse next time I make a mistake.
Yeah.
Sorry, boss. Cosmic ray flipped my brain bit.
Let me know how that goes for you.
I'll report back.
Oh, yeah.
One last risk source in Annex B lifecycle issues. Beyond 7. Yeah. Specifically, reuse.
This is a very common practice. You take a model trained for one thing and fine-tune it for another.
Like taking a model designed to identify cats and using it to identify tumors.
Exactly. It saves time. You don't have to start from scratch. But the standard warns that this reuse is a risk source. The original model might have hidden biases or quirks that didn't matter for cats but matter a lot for tumors.
For instance, if the cat dataset was mostly pictures of light-colored cats,
then the model might be less effective at identifying features on darker backgrounds, which could be a disaster when you're looking at medical scans.
And if you don't do proper retesting, you inherit all the baggage of the old model without knowing it.
Correct. And then there's decommissioning, the zombie AI problem.
What is zombie AI?
It's a system that is unsupported. Maybe the developers left years ago, but it's still running in the background, making decisions.
It's haunting the server room.
Basically. The standard mentions the risk of loss of information when an AI is turned off. That also the risk of keeping it running without oversight. If the world changes, dynamic principle, and the zombie AI keeps chugging along using 2015 logic to make 2026 decisions, you have a massive liability.
And you might not even know it's there until it breaks something.
Exactly.
This transitions perfectly to our final segment. Segment 6, the life cycle.
Yeah.
Annex C. It never ends.
This is the visual representation of the dynamic principle, the cycle. Inception, design meta verification, merit deployment, pass operation, retirement.
And it's not a straight line, is it? It's a circle.
It's a loop. Specifically, look at deployment. The standard highlights the transfer problem. An AI works in the lab, design verification, but fails in the real-world operation because real-world data is noisy.
So you deploy it, it breaks, and you have to go back to design.
Yes. But the most critical phase here is continuous validation. Because AI drifts, because concept drift is real, you have to keep testing it forever, as long as it is running. Table C.1 explicitly shows monitoring and review happening at every single stage. You don't just test it before launch, you test it on Tuesday, then you test it next Tuesday, then the Tuesday after that.
You're constantly taking its temperature.
You have to, because the data flows change, the attacks change, the environment changes.
It really is like raising a child. You don't just teach them, don't touch the stove when they're 2 and assume they're good until they are 30.
You have to keep parenting. And finally, retirement. Table C.1 mentions that retirement triggers a new risk management process.
Killing the AI is a risk in itself.
Yes. What replaces it? Is there a gap in service? Is the historical data readable without the AI?
Oh, that's a good point.
If you turn off the legacy system, do you lose access to 10 years of corporate knowledge because only the AI knew how to sort it?
So you need an exit strategy before you even start.
Always. You have
Yeah.
to plan for the end at the beginning.
Wow. Okay, we have covered a lot of ground, from the core principles of being integrated and dynamic, to the context of laws and fear, to the assessment of assets like democracy, and the wild risk sources like data poisoning and cosmic rays.
It is a comprehensive document.
So what does this all mean for the listener? If we synthesize this, ISO EC 23894 isn't about stopping AI, is it?
No, not at all. It's about making AI boring.
More.
Boringly reliable. It moves AI from magic trick to industrial machinery. We trust elevators because there are rigorous standards for cables and brakes and inspections.
Right. We don't even think about it.
This standard is trying to build the cables and brakes for AI. It wants to take the Wild West and turn it into a regulated, safe civil society.
So for you, the listener, this is your checklist for trust. If a company claims their AI is safe, don't just nod. Ask them. Have you analyzed the internal context? Have you checked for data poisoning? Do you have a plan for retirement?
Ask them if they accounted for the cosmic rays.
Chuckles, yes. Ask them about the cosmic rays. If they look at you blankly, maybe don't get in their self-driving car.
A sound strategy.
Here's a final provocative thought to leave you with. The document emphasizes over and over that AI systems are dynamic. They change on their own, they learn, they drift.
Right.
If the risk source, the AI is constantly evolving, faster than humans can write standards, can a static PDF like this ever truly be enough?
That's the big question.
Or will we eventually need AI systems just to manage the risks of other AI systems, an AI risk manager watching the AI worker?
It's likely where we are heading. AI auditing other AI, but then who watches the watcher?
Exactly. Turtles all the way down. Expert, thank you for guiding us through the maze today.
My pleasure. It was a great discussion.
And thank you for listening to The Deep Dive. Stay curious, stay safe, and don't trust the black box blindly. We'll catch you next time.